Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability in exercise 5.1 question number 26. Already in the last videos, I have uploaded solutions till 25 sums, so please do check it. Now let's start with the 26th one. Find the values of k so that the function f is continuous at the indicated point. From question number 26 to 29, we are going to find out the value of k. And what is the given hint here? Along with the function, they also told the function is continuous at the indicated point. So we have two informations in the question. Now using that, we have to find the value of k. Okay, so we have a f of x here and indicated point is x equal to pi by 2. So given in a question what they said, the given function is continuous at the indicated point. So f of x is continuous at x equal to pi by 2. We know that if any function is continuous at particular point, it has to satisfy one condition. What is that? F of pi by 2 and left hand limit and right hand limit surely will be equal only, right? Okay, when we will say it's continuous, if all the three values equal only, we will say continuous, no. So the same condition I have written here. Now, using the given information, f of pi by 2, left hand limit, right hand limit, we are going to find out. Then simplifying, we can able to get the value of k. Okay. Now, from the given question, if x is exactly pi by 2, what is the value of the function? If x takes the exactly pi by 2, what is the value? 3. So, we can directly replace here as a 3. Now, limit x is approaching to the pi by 2 from the left side. Okay, so here somewhere pi by 2 in a real line we have. So function is approaching to the pi by 2 from the left hand side. Left side closed values are approximately pi by 2, but those values are not equal to pi by 2 only, right? Okay, if it is not equal to pi by 2, what is the suitable function from the given? The first function. So replacing here, basically we will have a f of x. Here suitable f of x is what? K cos x by pi minus 2x. Okay, now similarly here as well. Now limit x is approaching to the pi by 2 from the right side. Right side closed values are approximately pi by 2, but those values are not equal to pi by 2. So suitable function is first function. Replacing here also first function k cos x by pi minus 2x. And understand one thing, in the left hand limit as well as in the right hand limit, we are using the same function. Okay, then obviously we are going to get the same result. So here either the left hand limit or right hand limit alone, further I am going to simplify. I am not going to simplify both. Okay, so let me choose this one, left hand limit. Okay, so now left side closed values are, as I told you, those are approximately equal to pi by 2, but actually not equal to pi by 2. So some small interval differencing will be there, right? So for that interval differencing, I'm going to make a substitution that x has a pi by 2 minus h. For example, if you have a 3 here, the closed values of 3, for example 2.99, if you take approximately 3 only, but those are actually not equal to 3, approximately 3. So to balance this interval differencing, it's what? It's less than the 3 only, no. So 3 minus some interval, that is h, we can take it. Okay, so here same way we can make a substitution, x as a pi by 2 minus h. Okay, x is what? Pi by 2 minus h. I'm going to replace wherever I see the x as a pi by 2 minus h. Then even in the limit also we need to change. If x is approaching to the pi by 2, okay, if x is approaching to the pi by 2, that means what? In this whatever condition we have taken, we have to replace x as a pi by 2. So pi by 2 minus h. Now pi by 2 take it to the other side. Pi by 2 minus pi by 2 equal to minus h. Pi by 2 minus pi by 2, which is 0, minus h, and h equal to 0. If x is approaching to the pi by 2, then h is approaches to 0. So now the limit as well as in place of x as a pi by 2 minus h, I am going to make a substitution. So now limit x is approaching to pi by 2 means h approaches to 0. Okay, now k, what is the cos x here? Cos x is, x is pi by 2 minus h, no. So cos of pi by 2 minus h. Now whole divided by pi minus 2. What is the x again? Pi by 2 minus h. Okay, now let's simplify this further. In allied angle, we know the formula. Cos 90 minus theta. What is the cos 90 minus theta? Sin theta. So here cos pi by 2 minus h, what is the formula? Sin h we can replace. So here limit h is approaching to 0, k we have, and here we have as a sin h. Now denominator also let's simplify. Pi minus 2. If we take the LCM here, what happens? If we take the LCM, pi minus 2h by 2. Okay. So now let me take, okay, we'll cancel 2 here. Now what we have here, limit h is approaching to 0, k sin h in the numerator divided by pi. This negative sign I'll take it inside. Pi minus into minus, plus 2h. Now plus pi minus pi cancel. Now what we have, limit h is approaching to 0, k sin h by 2h. So here we have the variable h only, right? So here uh, if we have a function in terms of h only, we have to take it. So other things and all, we have to treat it as a constant. So we can take k and 2 as a outside of the limit, because those are constants. Now limit h is approaching to 0, then what we have as a function, sin h by h. And now this is what? This is the standard result of the limit. So what is the value of this one? Value of this one is 1. So we can say that k by 2, and the value of limit x is approaching to 0. We have a standard formula for the limit x is approaching to 0, sin x by x value is what? 1. So here it is in terms of x, here it is in terms of h, only that is the difference, but value will be same only. Okay, 1. So k by 2. And here in the left hand side, what we had? 3 we had. So 3 equal to k by 2. Now simplifying this, what we will get? Taking 2 to the other side, 3 into 2 equal to k. So what is the k value? K takes the value 6. Okay. So that's all the solution for this. Thank you for watching, and please do subscribe. Thank you.